Okay, this is a similar problem of what we did before, and they're asking for the let's see, magnitude of the velocity, and probably they're going to ask for, determine the magnitude of acceleration. Okay, so in this particular case, let's see if we can do it. How many degree of freedom? There's 1 degree of freedom because the peg can move around in the white little curve. If you stop it from moving in the white curve, then everything else stops. So it's 1 degree of freedom. That means if you give me one angle, I can find distances that you want. If you give me one term that has 1 dot on it, I can find any term that has a 1 dot on it. So in other words, you give me one term with a dot, I can find any velocity. If you give me one term with a double dot, I can find any acceleration. And you're given that here, so you're given a single 1 dot term, and here, it says it's also constant. So because it's constant, theta double dot is 0. So I know I can do it. What you want to do is you want to ask, is this a tangent normal? Yes, you know, well, it's not, but you know the path, so that's good. But are you given speeds? No, you're not given speeds, you're given angle dots. So rule out tangent normal. And so in this case, it's a r and theta. Okay, step number 1, determine the r and the theta. The r, you draw a line from the center of from the origin, right, where all the r's and the thetas are measured from. Draw it straight out past that particle. That is the in r direction. That's the radial direction. You rotate 90 degrees off of that guy in the direction of positive angle. In this case, positive angle is counterclockwise. Don't memorize that it's always counterclockwise. It's not. You got to look at that angle. So you rotate 90 degrees in that direction of the angle, and that gets you the transverse direction, the theta direction. So those are your 2 directions. Then if you want the velocity and you want the acceleration, you basically write down the velocity equations, which I'll do, right? So the velocity is equal to r dot in the radial direction plus r theta dot in the transverse direction. And then you can do the same thing for the other one. So basically what you need is you need this. You need to know what is theta, what is theta dot, what is theta double dot, what is r, what's r dot, and what's r double dot. Those are the things that you need. Okay, so what do they give me? They tell me that angle theta is 68 degrees. So they tell me this, you know, they want to know what this is when it's 68. If they don't give you the angle, you cannot find the r. It's just that simple. Why? Because it's 1 degree of freedom. They have to tell you one thing. The theta dot, they told me, was 1.2. And the theta double dot, they said theta dot's constant, so theta double dot is 0. So how do you find the r? Well, the r is given by a formula. 4 sine of 2 theta. And so that's the r. So you just take your angle theta, put it in there, use your calculator, bang, bang, bang. Okay. So let's go get the derivatives. Okay, so here we go. R equals 4 sine of 2 theta. Okay. Here we go. So the r dot is equal to 4. Derivative of the sine is the cosine of 2 theta times the derivative of what's inside that, the sine. Okay, so that would be 2 times the derivative of theta is going to be theta dot. Does it satisfy the dot rule, or dot law? Yep, there's 1 dot there and 1 dot there, so I think I've done it right. Okay, so now let's go in and find the r double dot. The r double dot is equal to, now I'm going to treat this as a product, so I'm going to say that there's, well, let me simplify it a little bit. 4 times 2 is 8, so it'll be 8, and then it's cosine of 2 theta times theta dot. So I'm going to treat it like a product, so it'll be this term times this one. So the first term is cosine of 2 theta. Okay, so here we go. Bring the 8 out in front because it's a constant. The derivative of the first term times the second term. Derivative of cosine is minus sine of 2 theta times the derivative of what's inside the cosine term. So that'll be times 2 theta dot. That's the derivative of the first term times the second term plus the first term times the derivative of the second term. Let's see if it satisfies the dot rule. On the left-hand side, that term has two dots. Here's a term, and it has one dot, two dots. Here's another term, and it has two dots. So yes, it satisfies the dots. Okay, so what you'll do is you'll take your calculator, you'll punch in the values for theta, and you'll calculate the r. Okay, so you'll get it. Boom, got it. Then you're going to take the theta and the theta dot that was given to you. You're going to punch in, you're going to crunch it all out. You're going to get the r dot term. And then you're going to do the same thing down here, and you're going to get the r double dot term. The r double dot is not 0 in this case, even though this term here is, right, because of theta double dot. This term here is 0, but these guys over here are not. Okay, darn, stop it. Okay, so anyway, once you have your r dot, r double dot, you have your theta, theta dot, theta double dot, then you just plug and chug into all the different terms. It's tedious. You know, most of the mistakes are just algebra. Just make sure that you calculate it properly and you got it. Okay, that's it for this one.